Hello, today we're going to be taking a look at the complex zeros of polynomials. So what we're going to do is use the structure of complex conjugates to calculate complex zeros of polynomials. Now, we will have problems such as this, where if we're given that I is a zero of the following polynomial, we need to find all of our zeros. So we know that since this is a sixth degree polynomial, it's going to have up to 6 zeros, or it will be exactly 6 when we include multiplicities. When we're looking at this, it has all real coefficients, right? It's not that we have like, all right, well, one of the coefficients is minus 6i x to the fourth. So we have this rule here. If a complex number is zero of polynomial with all real coefficients, its conjugate is also a zero. So we'll talk about complex numbers in the form of z. So let's say that z is equal to I. Its conjugate, we're going to call that z bar, is the conjugate would be negative I. So if we're taking a look at the factors of this, well, this would be x minus I. This would be x plus I. Now what happens when we multiply those together? Now, when we multiply conjugates, we end up with the difference of perfect squares. So it'll be x squared minus I squared. Now, I squared is negative 1, so this will be the same as x squared plus 1. So what has to happen here is we need some more space. So we know that our zeros, we should make a list. So we know we have I, we know we have negative I. And then what we can do is do some long division with this polynomial as our divisor or our dividend, and x squared plus 1 as our divisor. Or is minus x squared. All right, and if you would like, you can write this as x squared plus 0x plus 1. We need some more space. All right, so x to the 6th divided by x squared is x to the 4th. We multiply x to the 4th by our entire divisor. We subtract the entire thing. Watch your signs. So then negative 2x to the 4th divided by x squared. Okay, so it's just long division like we've done before. Multiply that negative 2x squared by our entire divisor. All right, and then plus 1. All right, so then we take a look at this, see if it's something that we can factor, our quotient, which we can. We can factor this to x squared minus 1 squared, right? Because we have it to the 4th, x to the 4th, and then this is an x squared, and this is an x to the 0, so we're all good to go. So then we can factor that to x squared plus 1, x plus 1, x minus 1, because x squared minus 1 is the difference of perfect squares. So our other zeros then, we set each of those equal to 0, or 1, with a multiplicity of 2, and negative 1 with a multiplicity of 2. So the big thing with this, the new piece, is that we need to find the complex conjugate that is also a 0, and then find those factors, multiply those factors together, and do some long division. Let's take a look at another one. Now, this one, all our solutions, all our zeros, well, we know that I root 3 is a 0, and this has no real coefficients, so negative I root 3 also has to be a 0. So that's 2 of them. Now, we find our factors from that. So if I root 3 is a 0, x minus I root 3 is a factor, and then the same with x plus I root 3, because it'll be x minus a negative I root 3. Now, when we multiply conjugates, we end up with a difference of perfect squares. So we'll have x squared minus 3i squared. But I squared is negative 1. So this is x squared plus 3 as a factor, and that's going to be our divisor. All right, so x cubed divided by x squared is just x. Multiply that by our entire divisor. Subtract. Divide negative 2x squared by x squared. Multiply that by our entire divisor. Subtract these, watch your signs, and since x minus 2 is a factor, that means positive 2 has to be a 0. Now, what I'd like you to do is use the fact that negative 3i is a 0 and find your other zeros for this polynomial. For something like this, we are going to look more into in class to finish this out, but we can also have polynomials where the complex conjugates for zeros are binomials. So one of our zeros is 4 plus 2i, so the other 0 has to be 4 minus 2i. So our factors for that, we'll have x minus 4 plus 2i, and then x minus 4 minus 2i. So watch your signs with this. So when you distribute this, we'll have x minus 4 minus 2i multiplied by x minus 4 plus 2i. So I would write it out with this, watch your parentheses, and with conjugates, you're just changing one of the signs in the zeros. That does not change this sign in the factors. So when you multiply these together, just do it piece by piece. So let's just multiply the x by every term. So x times x is x squared. X times negative 4 is minus 4x. And then plus 2ix. Then we go through, take the negative 4, multiply it by each of our terms. So we'll have minus 4x plus 16 minus 8i. Then last, we'll do, so the negative 2i multiplied by everything. So minus 2ix plus 8i minus 4i squared. Now, when we're going through this, well, we have a plus 2ix minus 2ix minus 8i plus 8i. So all our I to the first terms, so all the ones that are going to have imaginary coefficients, are going to subtract to 0. So then when we combine everything else, well, we have x squared minus 8x plus 16, and then minus 4i squared. Remember, I squared is negative 1, so this will be plus 4. So then we combine those terms, so we'll have x squared minus 8x plus 20, and this is what we're going to use as our divisor with this polynomial. We'll finish this one in class. Thanks for watching.